everybody, back with the bonus quiz for 4.4. In section 4.4 we leap into two dimensions again, and right off the bat they want to know if an ordered pair 6, 4 is a solution to this inequality. And this is essentially a substitution problem. We're going to replace x with 6 and we are going to replace y with 4. And I'm doing this like this because about the only way you can goof this up is if you get the wrong numbers in the wrong slots. So we're going to have 2 times the quantity 4, which is what x is equal to, minus 3 times the quantity 6, which is what y is equal to. We want to know if the result of that arithmetic is less than or equal to 7. Is 8 minus 18 less than or equal to 7? And the answer is, of course it is. This is a negative number, and a negative number is less than 7. So the answer here is going to be yes. As I clear the board, keep in mind that I said in many places that substitution is the primary skill in this course, and here we are halfway through the book and we're solving substitution problems, and that will continue for the rest of the book. So substitution is a core skill. Now we're going to go into some graphing proper. They want us to graph the linear inequality, and here it is. And let me parse this apart for you a little bit. This is the solutions are going to be all ordered pair x comma y, such that when you subtract them in this particular order, you get a number that's less than or equal to 2. And so can I think of an ordered pair that works? And I can with a little bit of thought. Negative 4 comma 0 works. When you subtract these two, you get negative 4. Negative 4 is less than or equal to 2. And I could go on generating many, many points. There's going to be an infinite number of them, but this just gets me orientated as to exactly what the problem is asking for. What I need to do, though, is graph this, and what we do is pretend it's a line. We replace the inequality with an equal sign, and we graph this. Now this is nice because it's already in what's called standard form, alphabetical order, and a constant on the other side. That's really nice for graphing because we can generate the intercepts really easy. We let x equal 0 and we let y equal 0. Notice when x is equal to 0, let me switch colors here. When x is equal to 0, this is going to vanish. And we multiply both sides by negative 1 and we get y is equal to negative 2. That's the y-intercept. When y is equal to 0, this vanishes. And we can just read off what x is. X is equal to 2. And since 2 points define a line, I'm done, really. I just go ahead and locate those 2 lines, and then we need to draw that in. And the question is, are we going to use a hash line or a solid line? And the answer is we're going to use a solid line because it's lesser than or equal to, and the equal to is the line itself. All of these points on the line will satisfy the inequality. And the line divides the plane into 2 hemispheres, and the question is which hemisphere contains the points that work, and which hemisphere contains the points that don't work. Well, I know negative 4 comma 0 works. I know this works. And so this is going to be the hemisphere that works. If I didn't do that at the very beginning, find myself a point that works, then what you would do is you would pick a point and test it. And the point to pick, if it's available, is always 0 comma 0. Notice when you put 0 for x and 0 for y, you get 0 less than or equal to 2, and that's true. That's why this hemisphere is the correct hemisphere. So all that's left to do is to fiddle with the controls of MathXL and get that answer in there. Let me see if I can manage that. I want to do a line. Here's one of the points right here, and here's the other point right here. And we set everything up this side, so I'm going to select that side, and I'll say save. And we're ready to do a submit. Keep our fingers crossed, and voila, both are correct. So that's 4.4, not too difficult, and I'll be seeing you in chapter 5.